Hello everyone. This is Taeyong from Midas IT. So thank you for coming today. We are going to walk through mastering Midas Civil series on Midas Academy. So today is fourth time of mastering Midas Civil. So we had 3 lessons about the basic training about Midas Civil. So today's subject is section properties. Okay, so here are today's content. The first one we will look into section properties of Midas Civil. After that, there is additional function to make the user defined section. We called it sectional property calculator. Short form is SPC. So we will see how to use SPC function to make our own section. After that, we will see additional options for section properties in Midas Civil. And lastly, we will look into about the frequently asked questions from Global Technical Center of Midas. Okay, so first topic is section properties. So I will show you a quick demonstration about how to create section properties and which which section types Midas Civil has, like that. So let's go to the Midas Civil. So where? Oh, okay, I will turn on the Midas Civil. Okay. So I'm waiting the opening Midas Civil now. Okay, okay. Okay, got it. Okay, so I click the new project here. Actually, I prepared other one. Okay, this is a sample model of Midas Civil. So I bring some the simple model. It has a 6 beam element and no section, and it has 1 material properties and 2 boundary condition. So this is simple single span beam. So to create a section property, you can see the properties tab here, and in the below side you can find section properties. If you click this, the properties tab will be popped up. So if you want to new section properties, just click add button. So section data dialog will be opened, and you can define the section properties here. So you can select the database in the each national code, or you can input directly for your section. So I will create a simple model here. And after defining a section, and if you want to modify existing section, just select existing model and click modify. And after that, adjust some value here, click OK. And if you want to copy the existing model, just click and copy. The section properties can be able to have the same name, but it it should be it should have unique number ID number, because MyDataSibid manage the section properties data using the ID number. After that, if you want to delete the section property, just click the delete button. And also you can import section properties from the existing model file. So for that, click the import button and find the existing model and bring this model. And if some ID number is duplicated, you can assign the new ID number here. So we have a 4 section properties like this, and also by using renumber option, we can rearrange. We can reassign the ID number again here. Let's see. So the beam element has number 1 section here. So in the model view, you can assign the section property to the element. So this is hidden view. You can find hidden view in the upper side of model view. It shows the element with the section like this. So if you want to change the section, just select the element and select the section properties in the worst tree and drag and drag down. So we got other section here. Okay. Let's move back to the section properties. Yeah. So there are a lot of tabs to define the various section shape. So let's walk through all of them. So there is DB user and value, and the steel reinforced concrete section, and the combined section, and pre-stressed concrete section, and tapered section, and this is composite girder section, and the last one is steel girder. So you can see in the all tabs, you can find the consider shear deformation option and consider warping effect option and change offset option. you can see. So this is the common option for all section properties. The the first one is consider shear deformation. It it is uh, it is to select the element model type between the Euler beam or Timoshenko beam. So if you check on the consider shear deformation, you can the software will consider the deformation due to deformation in the section plane due to the shear force. So the engineering word is Timoshenko beam. So if you don't want this Timoshenko beam, you just check off this option. After that, the software will consider only the bending strain like that. But basically, software check on the consider shear deformation here. And then next one is consider warping effect. This is if you check on this option, you can consider a software will calculate the warping effect. Actually, this option is developed for EST code usually, and then also you can find the change offset. Change offset is, let's see. As you can see, the blue one is centroid position of this section, but the change offset can change the position of central point of section to the below side or upper side or left side, or we want the where we want. So I will give you more detailed explanation about change offset after the next slide. So the concept is we can change the section, the position on the element like this. So if I change center to center type, the section location will be changed. Okay, black. Okay, I see. Okay, I change the background color as a black. Okay. Okay, let's go to the section properties tab again. So now we will look into DB user section. So DB user section has the various section template like angle, channel, T section, I section, or solid rectangle, or solid octagon like this. And it has the user type and DB type. DB means database. So if you select the DB, so you can select some national design code like British Standard or KS Korea for Korean, and IES and AISC. After that, you can select the DB section here. Or if you do not want to use the database section, you just select the user type and put your own value to define the section like this. And then after enter the dimension of section, you can see the section properties. It is important for the analysis. So you can see the section properties here, show calculation ledgers. So this option shows the area, a second moment, inertia, or other centroid position like this. and yeah, it shows the section properties. So the DB user, when you in the DB user, when you enter the dimension for the section, this tab will calculate the section properties automatically. Okay, let's move on the value type. So this is a value type. It is also the similar to the DB user tab. Especially in the value type, you can import the section file, which is defined in the SPC sectional property calculator. So you can import your own section file here. And also you can input, let's see, and also you can input the section size. You can also input the section property directly. So when you do not want to section shape, only only want to section properties, so you can just input the section properties for your analysis like this. So this is area. Just calculate the design report like this. So you can input the section property in manual to create the section. Let's say like this. YZ like this. So you can modify or value or other things here. Okay, let's move on. And next one is PSC section. The PSC is pre-stressed concrete section. There are there is some various section like PSC box girder and multi-cell girder like this, and PSC mid girder and PSCI. The mid the PSC mid and PSC hop girder type is for this kind of multi-cell box girder. So we can when you model this multi-cell box girder as grillage model, there are some girder element. So you can put the PC mid in the middle side, and you can put the PC hop section type into the at the both end here. And then yeah, and PCI is can be used as a just I section. And also here is PCCMP web section. It means it means the PC girder with corrugated metal panel. So like this girder. So let's see. And when you use template section, we can see a lot of options to define the section shape. But if you have a plan about analysis only, because the Midas Civil has analysis function and the design function, but sometimes we want only analysis function. So as you can see, there is a share check and web thickness. So those are for the design feature. So if you want to the analysis model only, you can ignore this option. So I will when I make a model for the analysis, I just check on the auto option. And also you can find the message size for stiffness calculation. Actually, the PSC section has like a plain section here. So the internally the MyDACB calculate the divide the section with using the mesh. After that, the software gets its section properties. So you can control the message size for the calculating section properties, but it is actually not it doesn't affect quiet to the calculation sections properties. So you can normally you can ignore this option. And also when you design your bridge model, sometimes your section is not typical section. So here you can import your section data, or you can define the section shape with by the coordinates. So let's see. So I will click the define by coordinates option. So here you can input the coordinates of your section to define the section shape. So let's see. Here is the example. And so I will create this shape of section. So I extract the coordinate. So I need one outer polygon number and inner polygon number. So I have three dialog, and just copy and paste them into here. So you can see the section is created. Yeah, so you can define the PSC section by coordinates. And also actually you can input the section properties directly. So the PSC value type is similar to the value section. But if you want to use the design feature for PSC, you should make your section as a PSC value. And also here, section data. Under the section data, there are two options. One is database and import from SPC. So here's the DB. DB has some national code, and each code has the national section type like this. So there are UK, Italy, USA, Australia, New Zealand, and Russia. So you can select one, just click OK to import this section. Yeah, and next one is import from SPC. So you can import section file directly like this. And also it has the share check and thickness for torsion option. So you can input the you can use auto option and input so 1 millimeter or 1 meter, whatever. If you it doesn't care what it doesn't matter when you have analysis only. And also if you don't want to the design feature, you can input any value here to create the section. Okay, and next one is composite section. The composite section has steel composite, so slab and the girder, steel girder. So here is a box girder, and here's eye, and here's top girder, and also it has composite PSC eye girder and composite PSC T girder. Sorry, it has PSC composite PSC girder. It means you can import PSC value type. And also if you create your section from as in the SPC, you can import section file here. So here's the example. So as you can see, you can import composite section. And last one is user section. You can just assign the before composite and after composite the section from the DB or value type. Okay. And when you create steel composite girder, there are two types, type 1, type 2. So type 2, in the type 2 steel girder, we can make a symmetry section, a symmetry slab section, actually. So, and also type 2 steel composite section is developed for the Russian design. So if you want to perform the Russian design, you should choose a steel composite girder type 2. And also there is a limitation of type 2. It is if you want to use steel composite girder wizard here, steel composite bridge wizard. This wizard For this wizard, the steel composite girder type 1 is available only. So that is the big there is a differences between type 1 and type 2. So if you have just analysis only, you can use both them freely. Okay. And the last one is tapered section. So tapered section has a lot of template in the other tab. So we can make a tapered section using PSC or composite section or or uh, or SPC section like this. And also, if you choose some typical section, you can import section from the database. And also, you can input the dimension of section directly. And also, you can input their section properties directly here. Okay, so that is some summary of section properties here. So let's look into the how to use sectional property calculator SPC. So I will learn as sectional property calculator. So I prepared three types sections for SPC. But due to the time limit, I will show you two types: the concrete box girder and steel eye composite girder. So you can try to create your section using this material. And also you can find some more detailed description about the section data dialog and other things in the presentation. Okay, let's go back. So when you open the sectional property calculator, the setting dialog is popped up. So it is important to set the unit system, because when you create the section, you can draw the section based on meter unit or millimeter unit, like this. So I will use the millimeter here, and then you can import the AutoCAD file. So I will import PSC box Godder. So here is the example, the model, and to create our section, go to the section model tab and section and generate. And there are two types, plain line. So we need the section here. So close the section. So we will use plain type, and input your input name, and you can check on the calculate properties now or not. I will use it, and select the lines and click apply. So in order to if you want to check the section properties, which is calculated automatically, you can find properties and the display section, list section property. So if you click here, you can check the section properties along the select section. So after creating section, we will select export in the section tab, and select the MIDAS section file and click this button and input the section name. Oh. And select the section and click apply button. So after that, you can find created the SPC section. So after creating a section, you can import the value in the value type, or you can import in the PSC value type for your. So it is depending on your purpose. Let's go back. So I will create steel composite girder now. So I will open the steel composite girder section. So as you can see, the steel girder doesn't have their whole section. I just bring the center line of the plate, steel plate, because the steel plate has is too thin, so it is hard to calculate section properties with mesh. So at this time, in the SPC we will use assign the width here. So it will help us to calculate their section properties. So when you have a plan to make a steel girder, so you need to draw the center line of steel plate like this. So after importing the section, we need to define the section material, because this is composite section. So the software need to calculate the section properties using the material, the ratio of the mechanical properties, like the ratio of elasticity, the ratio of density, and we need also Poisson ratio. So I will input that. So the first one is slab, and also this value is not provided automatically in SPC, but you can refer this value in the MyDasCivil like this. So you can get some default value for the elasticity, modulus, and Poisson ratio, and weight density. Okay. So I need two types, the concrete and for the steel. Okay. After that, as I mentioned, I need to assign the steel plate width. So I will click the change width in the curve the tab. So I will assume the all steel plate has 30 millimeter, and to create the composite girder section, go to section and find the composite section and click generate. So we need to create the whole composite section name. So steel composite. So it is steel composite, and there are two parts. So part one is the steel girder, and part two is the slab. So this is the number of the number of section. So we have two parts, and the base material is in the steel composite section. We usually the steel material uh, make the steel material as a base. So I will select the steel material here and apply. So you can see the U composite section with part two, two parts is generated. And after that, we will assign each part to the whole section. So go to section and composite section again and add part. So I will first of all, so you can select the part one or part two. So I will start with part one. So part one is steel, and it is the line type. So you can change the part color, but is not important. And just select the steel girder and click apply. And I will assign part two. So select the part two and the plane type, and select the slab and click apply. Okay, so I assigned the geometry to the part. So I need to calculate section properties. So you can calculate the composite section uh, in the properties. So calculate composite property and input the mesh side and select the section and click apply. So you can see the properties composite section are calculated, and it is also checked via the table. So you can check the before composite and after composite. Oh, I assigned the same name, so it showed this value. So after creating the composite section, we will export this section to the MIDAS Civil. So go to section and composite section, and there is export option again. So set the name and select the composite color and click apply. Okay, move on back to the MIDAS Civil, and here we can import the steel composite section. Actually the composite color section from SPC, it it is it is not imported in the general section type in the value. So when you try this, you can see this pop-up message. So we need to move on to the composite tab and use composite general option. Here we can import the composite section. Okay, so it is the how to use the SPC section, SPC function in MIDAS Civil. Okay. So now we will see the additional option about the section properties. So I will open another file. Okay. So we will see the how to use the tapered groove function. So you can find the tapered groove function in the properties, under the properties. So because when you assign the tapered section into the element, maybe you can see that this model view first. So it is not proper tapered section. So we need some additional step. So the tapered groove will help us. So click tapered groove. The usage of this function is really quick. So input the tapered name and select the element list, or enter the element list, and you can select the variation method for the z-axis and y-axis. So there are two types, linear and polynomial. So let's try the linear type. So if I click add button, so the tapered groove will make the additional section in the middle side, and also you can modify some variation. So under using this option, so I will try the polynomial modify. And if you don't want this shape, change the I or J, or also if you you can change this value to adjust this curved line. Yeah. Okay. So after creating this section, you can find the tapered section group in the work tree, and also the software can import the individual section to section. So that option is compare to tapered section. So select the tapered group and compare to tapered section. So if you click this and input the ID number, it will generate additional section in the middle side. So you can see there are additional taper section. So you can see more detailed section properties in the middle side. Okay. And also actually we have a section manager. Let's go to the section manager. The section manager can be used to input the scale factor for the correct section or the long-term section, etc. And also you can see the more detailed the shape of section. So this is each it means the element, the element number 1 and element number 2. So there are 3 types in the section manager. So one is stiffness and reinforcement, and third one is stress point. Let's see. The stiffness show this. If you choose a stiffness, it shows only section which is assigned to the element. So, and also each element will show their section, and also you can see the section for the five parts of element. So this is IN, this is JN, and these are the quarter part and the half length and third quarter. And also each part you can see the stiffness. Stiffness means section properties. So without creating the additional section, you can check their detailed section properties here. And also, if you have a tandem profile in your section, like this cantilever, balanced cantilever girder, bridge girder. Oh, sorry. We have this kind of tandem profile. We could have this profile, and sometimes we need to check their coordinates of their coordinate for the tandem profile. So at the right below side, you can see the detailed coordinates of tandem profile. And also to see, if you want to see the tandem profile location, check on the tendon and properties and duct core. So here you can see the graphical view, and also the exact coordinates of this tendon profile here. And if you input the rebar reinforcement, you can check the rebar the coordinates here. And here is the important part of the section manager. So you can input the scale factor for the correct section or other section part. So you can input the scale like this. And you can find the boundary condition. So it is, if you want to assign the different section section that has a different scale factor to the different load case or different construction stage, we need to assign the boundary group. So after make this section scale, you can see the group, assign the group. So you can use this group in the construction stage. So you can activate the scaled stiffness, or go to the analysis tab, and here is the boundary change assignment, and you can find the section stiffness scale factor. So you can select the boundary group here. So make the boundary group, and other, you can also add other boundary condition here, and you can assign this boundary group to check the effect of the scaled sectional properties. Okay, and let's see other section. Okay, I bring some with leaders. So we remained reinforcement and stress point. So reinforcement shows all section, and also you can input the longitudinal reinforcement and the shear reinforcement here. So there are two types to define the reinforcement. So actually this input for the design feature of MyDASB. So after this webinar, if I conduct the webinar for design features, I will input this more detail about reinforcement. And so if you define the reinforcement, and if you want to get some effect, the reinforcement for the analysis, actually you can find the main control data in the analysis. Here you can see the consider reinforcement for section stiffness calculation. So it means the software consider the reinforcement area or other section properties to calculate the section stiffness for the analysis. And here is stress point. So this stress point shows the all section, and all section has their stress point. So you can see the number, the 1, 2, 3, 4, 5, 6, etc. So if you define the PSC section, it has the 10 points as a default value, and another section has 4 sections, so 4 points, so 1, 2, 3, 4. It is regarding the leisures is section stress beam stress option. So as you can see, there is a 1, 2, 3, 4, right? So for the default value, for the default section, you can see the stress leisures at the point number 1, 2, 3, and 4. And also there is the beam stresses leisures function for PSC section. So we called it the beam stresses PSC. So as you can see, there are more points in the example figure. So let's see. So when you check the ledgers table will show the ledgers for the 10 points. So 10 points is, let's say, can be matched to these 10 points. And the additional option is we have MITRE Civil has a beam detail analysis function. So from this function, you can check the more detail between the node, detailed ledgers between the node I and j for the each element. So I will check the element number 1. Okay. Okay, we will see the presentation because it takes a bit of time. So yeah. So after using this function, we can see the more detailed the ledgers about for the 10 points. And also you can see the section manager here. So you can, if you click the section manager, you can move to the section manager option. And here you can add more point to check the ledgers. So after add the point here, click and click the apply button, you can see the additional ledgers in the beam detail analysis ledgers. Okay, it is working now. Okay, let's see. Okay, let's see the main part with the presentation. Okay, third one is plate stiffness scale factor. So if you want to design, if you want to model the crack the plate element, we have a two choice. So one is define the orthogonal material properties, and the other one is use the plate stiffness scale factor function. So you can just select the plate element and input some scale for the each side and just click apply button. And here's effective width for the calculating the bending stress. So you can define the effective width in the boundary menu, and you can find effective width here. So you just select the element and input the scale factor here. And also the effective width function can be found in the structure menu. So go to the structure menu, and there is a 3-type PSC bridge and composite bridge and steel girder bridge, and it had each option. So first of all, you should define the span information, and after that click effective width, and it has each design code. So after entering some value to calculate some effective width, so the software will calculate the effective width here. And this is the last part of today's webinar. So frequently asked question. So question number 1 is, I got elements which had distorted sections, and sometimes taper section appears one line like this. When I define a taper section using a section from SPC, what happened? So this issue is regarding the vertex of section. So as you can see, the all section properties are inputted properly, but the graphical view doesn't show the right section view. So, but this issue can be happen happen for the various regions. But here is the one region. So when we create the section from index SPC, we need to create a node and connect the node by a curve. And also sometimes we can import the drawing file from the AutoCAD like this. So let's say we have a three section. So you when you make our section, sometimes we have a mistake to draw another section, like using this section and and modify or adjust this section like this. So sometimes it makes some vertex issues. So as you can see, there are 2 additional vertex. So it has 3 vertex, 1, 2, 3. So but this section is similar to this section, but it has just 2 vertex. So at this time, to avoid this issue, we should divide the line to get the 3 vertex. So I divide this small part. So I have 3 vertex, 1, 2, and 3. So after modifying this line, so we can get some more proper graphical view for the taper section. Okay, next one is, when I check combined stress ledgers, it doesn't appear reasonable values. Yeah. So it is, to solve this issue, we need to check the model in various ways, but sometimes you can find the solution in the section properties, because before checking the region, we need to understand how to calculate the stress ledgers in MIDAS-CIBIL. So we can see, when we check the beam stress ledgers table, we can see the component, so axial stress and bending Y, bending Z, and also we can check the combined number 1, combined number 2, and 4. So at this time, the software used a different value to calculate the stress ledgers. So as you can see, to calculate bending stress for y-axis, it used the CYP. CYP means the length, the distance between the centroid of section to the outer section of outer section. Okay. So you can see the CYP and CJP like this. So CYP can be the y-axis, the positive direction, so the distance between the central point and this side, this side. And the CJP means that in the z-axis to the positive direction, but sometime the point, the 4 point doesn't match it. I'm sorry, doesn't match it to the CYP or CZP like this, because when you use the value type, okay, like this, we can modify the y or the point location here. So it can be modified it like this. So you can see the moved point here. And sometimes when in SPC, when you use SPC, and the SPC calculates the section properties, but sometimes if the section is complex, has a complex shape, the SPC doesn't calculate the proper the location of 4 points. So sometimes this issue is happened. So this example is not matched the point location to the CZM or other things. And last one is it necessary to use change offset option? Yeah, where is mouse? Oh, I'm sorry. So I would say it is optional. So using change offset is depending on designer's decision. So when change offset is applied, the centroid point will be moved to assigned location. So in perspective of graphical view, the section is just moved with some eccentricity length, but in other view like software will make a U structure that has elements with link between the original point and moved point like this. So therefore, as shown the figure, where's the mouse point? Yeah. So as shown the figure, the software calculates analysis with the internal structure condition. So when designers build a model, they might have some assumption like to ignore extra forces due to it is too small. So change offset is to modify boundary condition and structure condition. They might face unexpected results depending on their modeling state. So therefore, I would like to recommend to use it on a case by case and to check the effect of change offset. So this is some example using change offset. So you can use change offset to avoid creating additional link between the gutter, or to avoid the graphical issue for the balanced cantilever bridge. And also you can use the change offset option to make up the glitch model in the same plane, and also same plane, and to want to get the more proper results from the analysis.